Okay, so I included this question. This is question 1 from the April 16th distance learning assignment. I included this question with the L'Hopital because it's a fraction, and when you put a 0 in on the top, you get a 0, and on the bottom, you get a 0, and you get 0 over 0, which seems like it would be a L'Hopital's rule situation. The tricky part with this one is if you notice, it's the h that's going to 0, and it's not the x. So when you attempt to take the derivative, you've got these two things going on. You've got h, which is a numeric value that you're taking to 0, and then you've got x, which is the actual variable of the problem. And so the reason I included this here is you actually don't use L'Hopital's rule to solve this. The h and the x combine to make this really a tricky one to look at through that lens. What this is actually assessing is your ability to recognize the definition of a derivative. So this is the definition of a derivative. It's what it means to be a derivative. It's something we looked at way back in probably late September, maybe early October, but I think late September. And that general form is the limit as h goes to 0, f of x plus h minus f of x all over x plus h minus x. And that's the idea of, and then the bottom, the x's cancel. And the condensed version that they're looking at here is just subtracting the x's on the bottom and getting h. This is slope, and this, I know it's so long ago that we talked about this, but this is rise over run. So change in y, that's on top, and change in x, that's on bottom. And then what we're doing by making h go to 0, h is the gap that exists between the 2 points. So we're using this tool of a limit, and we're applying it to the slope equation. So the slope formula. So this is the slope formula, and this is applying the notion of a limit to the slope formula. And it's actually where calc begins, this idea of finding the slope at a specific point. So what this problem is asking you to do is actually nothing mechanical. Well, at least not yet. They're asking you first to just recognize that you are taking a derivative. This is saying take the derivative. So take the derivative of, oh, that can't be right, derivative. Yeah. Take the derivative of whatever f of x is. Well, f of x is tangent of 3x. So you can see that is what's sitting right here. So take the derivative of the tangent of 3x. Well, the derivative of the tangent of 3x, derivative of a tangent is secant squared. Leave the inside alone and then times by 3. And then that's it. Your answer is B. So you do not need to use L'Hopital's rule here. And if you do, it's really confusing to figure out how to deal with the h and the x, both being these changing things, where the h is the thing that's going to 0, the x is the thing that's free floating and not being taken to 0. So again, this is actually falling outside of L'Hopital's rule in terms of what they're asking. They're asking you to recognize this thing as the definition of a derivative. So hopefully that helps clear up what was going on with this problem.